Well, hello Internet, and welcome to my Scala video tutorial. In this one tutorial, I'm going to teach you pretty much everything you would learn from a standard 200-page book on Scala. I'm going to teach you how to install everything, and we're going to work in the terminal, and we're also going to work with compiled Scala code as well. And you may ask yourself, well, why would I care to learn Scala? Well, Scala is the perfect choice if you want to explore the world of functional programming without completely disregarding object-oriented programming. It has both. And on top of that, what's awesome is Scala runs on the Java virtual machine, which means that it's going to have a ton of libraries ready for you to use. Another thing I wanted to bring up, I answer every comment that I get down below. The only situation in which I cannot physically answer your comment is if you do not have a Google Plus account. So if I don't answer your comment, that is the reason why. I just wanted to bring that up because it's come up a lot lately. Alright, let's jump over and I'm going to show you how to install it on both a Mac as well as on Windows computer. Okay, so if you're on Windows or you're on Mac or you're on Linux or whatever, you're going to need the Java virtual machine. So you're going to want to go to java.com/en, or maybe not, just download the Java virtual machine, click on free Java download, and do all that stuff and get that installed because that is required. If you are on a Mac, it's pretty easy to install. What you're going to want to do is to go to brew.sh and install Homebrew. And then inside of your terminal on your Macintosh computer, you're just going to type in brew install Scala. That's it. Hit enter. Everything's going to install for you. You might need to update it, and that's it. So that's all you need to do to install on a Mac. Now I'm going to show you how to install on Windows. Now, of course, you're going to need the Java virtual machine just like before, but you're also going to need to go to scala-lang.org and then download. And then on Windows, you're going to click on this guy right here. It's going to pop up a little message at the bottom. Make sure you want to save it. Click on Save. And then it's going to start installing everything for you. And this is just basically going to be a whole bunch of next clicking. So click on Next. And then it's going to have this. Click right there. And then click on Next. Everything here is fine. Click on Next. And then click on Install. It's going to take a little bit of time to install. And you just have to wait for that to happen. And then what you're going to want to do is you're going to type in envir, environment variables, whatever, and then you're going to click on edit the system environment variables. The reason why we're doing this is we need to put Scala in your path. So you're going to want to click on environment variables. This guy's going to pop up. You're going to want to click on path and you're going to click on edit then. And then you're going to want to copy and paste the location for the bin folder for Scala on your Windows machine and click on OK. And then after you do all that, you're going to be able to go into your command line and then just type in the location for Scala and it's going to be ready to go. So the only difference between what I'm doing here is I'm going to be using a Macintosh, but aside from that, everything will be precisely the same. And for anybody that wonders, I use Notepad++ on Windows and I use Sublime Text on a Macintosh. So enough talking about installation, let's start writing some code. Okay, so right now I'm in the terminal, and if I want to, I'm going to do some work inside of what's called the REPL or the read, evaluate, print loop, and then I'm also going to work with compiled Scala code to give you an example of using both of them. So you can see I'm logged into this, and I can just simply come in here and do some addition, and of course all of the code I use here is available in a link in the description. So there you can see I went and just threw in a whole bunch of calculations and it automatically popped back not only the solution, but it also assigned it to this variable right here. Once again, I'm inside of the terminal or the command line if you're on Windows. You're also going to be able to come in here and do things like your answer, and then plus, and then use res0, which is this guy right here. And you're going to see that it pops back that information. You're only going to use semicolons in Scala if you have multiple statements per line, but if you feel comfortable using semicolons everywhere to end all your statements, feel free to do that as well. You're also going to be able to come in here and do things like create different variables, and it's automatically going to decipher the data type based off of whatever data you store inside of it. So this is a string, as it says right there, and you can see right there it says this is an integer. Now whenever you define a variable with var, that means this value is going to be able to change. However, if you go and define a variable with val and my age 40, that is going to be a constant, and this value is not going to be able to change. So var is able to change and val is not. You can just think of it like a variable's value can change while a value itself can never change. Now there's numerous different data types available in Scala, and you can see here how to comment, just 2 forward slashes, and if you want to do a multi-line comment, you can just do multi-line like that, and then another star to close that off. Whoops, put it like this. There you go. That's a multi-line. That's a single line comment, just like Java. And you can see here your bytes and how the minimum size and the maximum size are going to lay out. There's booleans, true or false. You can see here they are lowercase. Character is going to have an unsigned maximum value of 65,535, and you can also see all of the other different data types and how extremely large they are. It's also important to know that you can create doubles inside of here. However, they are only going to have 15 digits of precision, so it's very important to remember that. After that, your floats are going to lose precision, and of course that's true for all data types in all different programming languages. However, we will be able to create what are called big integers. So let's say we come in here and we create a large prime number. How we would do this is we would go equals to, and then we would say big int, and then you could put your quotes, and then you could throw in a really large number inside of there, and then you're going to close that off, and that is how we would be able to create a big integer, and it's going to hold that size, and it's going to make sure that it works. So now of course we could come in here and do something like large prime plus 1, and it's automatically going to go in there and add that in. You can know that that's going to be true. We also have what are called big decimals, and let's just go and create a big decimal. Let's say pi to 50 digits, and we're going to define this with big decimal like this. Paste in that big number, close the quote at the end, and there we go. Now we created a large decimal that's going to hold its precision. And then we'd be able to come in here and go and add 1 to that value. And you can see that if you go and look at these values the whole way down here, this ends with 751 and this ends with 7511. So it's pretty impressive we're able to use numbers that large. Another thing's kind of neat. Let's say we come in here and go rand integer, and then let's just throw 100,000 inside of it. This is inside of the terminal. We'll then be able to come in here and go rand int and then dot, and then if you click on tab, it's automatically going to show you a whole bunch of different methods you're going to have available here. And all these different data types that I've talked about, they are all objects inside of Scala, so they all have built-in methods that are very useful. You're of course also going to be able to come in here and do all the common types of arithmetic that you'd like to do. And 5 plus 4, right like this, and you can see that that's going to add itself. Of course, we're going to be able to do the same thing, 5 minus 4. And you can see we can also do subtraction, we can do multiplication, we can do division, and here I tried to do modulus, but I messed that up. Let's just come in here and do this. And there you can see we can also get modulus, which is going to give you the remainder of a division. So all the common different math types that you're probably well aware of. We're also going to have shorthand notation. However, if we had random int, Scala does not allow you to do plus plus like that, or minus minus, or whatever like that. However, what you can do is just add 1 to a value, so you can go in there and do that. And equally, we would be able to come in here and go random int and subtract 1 and then reassign it back to the value for random integer. So you could put that in there like that. You could also do a multiplication like that. And of course, you don't have to use 1. And you could also do a division like that. So put a 4 inside of there like this. Now if you want to import a library directly inside of the REPL or the inside of the terminal, all you would do is just go import scala.math and then dot and then an underscore, and that's going to import all the different libraries that are available to you. And then we'll be able to come in here and do things like get the absolute value, get the cube root of a value. You'll also be able to come in here and get the ceiling, so it's something like that. We would be able to round a value, see exactly how that rounds. Floor is going to get you the bottom, or it's going to round down. You could come in and get Euler's number raised to whatever power. Just put 1 inside of there to get Euler's number. We could do power 2, there we are. Square root, and we could do something like power of 2 plus power that. You can see you can combine all kinds of different things inside of here. Be able to get the hypotenuse. There you go. That's exactly the same as the calculation I just performed. Log to the power of 10. There we go. You could get the natural logarithm to the base of e, just like that. Of course, we have minimum and maximum. And of course, sure you know how that works out. And also you could come in and calculate random values. So let's say we wanted to do something, all we need to do is go random like that. And then you could put in 11 minus 1. And what this is going to do is give you a random number between 1 and 10. And if you want to convert this into an integer, you just go to int, right like that. And you can see right there, give us a random value. We can come in and just do this all day and night. There's a whole bunch of random values. And then finally, we could come in and do something like the radians. And then finally, we could come in and get the degrees. So there's a whole bunch of different math functions that are available to you with Scala. And of course, I'm going to show you how to do this in a compiled way here in a minute. Now let's go over and take a look at conditionals. Now your conditional operators that are going to be available to you are going to be equal to, not equal to, greater than, less than, greater than or equal to, less than or equal to, and that's pretty much everything. And then your logical operators are also going to be familiar if you're used to using Java, and, or, and not. Let's go and create a couple examples here. So let's create an age and have that be equal to 18. Now if statements inside of Scala are going to be similar to Java, except they're going to return a value kind of like we're used to with the ternary operator inside of Java. So let's go and let's just give a demonstration of this. We'll say can vote, and we could say if, and then we'll say age is greater than or equal to 18, and then we would say something like yes, else, no. You can see how the results work out there. We might as well give a demonstration of when we'll use curly brackets and when we won't. So inside of the terminal that we're using here like this, we're going to have to use curly brackets. However, normally you do not need to use them inside of your code. And let's just go and age is less than or equal to 6. So here we're going to use curly brackets because the terminal needs to know, to allow you to continue typing in code. And we could do something like print line. This is how we print out to the screen. There's a whole bunch of different ways to print out to the screen. And garden like that. Close that off. And then we'll close off the first if statement. Then we'll go else if. This is how we would check multiple different conditions. And we can come in here and say age is greater than 6 and age is less than or equal to 7. It's doing a simple calculation to figure out exactly what grade a student would go to. And then under this situation, we could do print line. Print line, of course, is going to print out everything that you put in between quotes, and then it's going to add a new line to your screen. And then we'll close that off, and then we'll say else, and then in the last situation we'll go print line, go to grade, and then of course we're going to be able to use plus, and then inside of here we can throw in any type of calculation we'd like to use, and of course there's numerous ways to do that, and there's that. And then after you hit that, it's going to tell you what grade you need to go to, which was 13, and the reason why is we had this set for 18. Here it subtracted 5 from that, and that's how we get grade 13. And of course we could come in and do some Boolean calculations, so true or false. Basically it's going to come back true if either one of those is true. And that's a rough overview of how we can use conditionals inside of Scala. Now I want to jump over and start writing some real code. Okay, if you want to exit out of the Scala terminal, you just type in colon and Q, and that's going to exit you out of there. And now let's start writing some regular old code. What we're going to do here is we're going to type in object, and then this is called Scala tutorial with the Scala exemption on the end of there. And I'm going to call this Scala tutorial right like this. Put some curly brackets, and then inside of main is where we're going to be writing our program code. And there's arguments that can be accepted inside of this guy right here, all going to be considered a string, and we'll get more into arrays later on. And let's just write some code here. So we'll go variable. I'm going to go over looping here just to start off. I'm going to create a variable that's value can change. See, it says var. And if you wanted to create a while loop in here, we'll just go I less than or equal to 10. Like I said, you can use the curly brackets if you'd like to. I'm a hardcore Java guy, so I like to use the brackets, but of course you don't need them. And then we can use the shortcut to increment the value of I. Now to compile this guy, you can either go in here and go Scala C like this, and then type out Scala tutorial.scala like that, or you could just go Scala tutorial.scala and get exactly the same thing right there. You can see that it went and it looped through values between 0 and 10 with our while loop. There's also do while loops, of course, and you're going to use do while whenever you want to guarantee that you're going to go through the loop at least once. And we'll just do print line I. You can see there I'm not putting the semicolons at the end, even though I'd really like to because I'm not a Java guy. And in this situation you're going to put the while condition at the end. So you're you're going to say we're going to continue looping through this as long as I is less than or equal to 20. You can see if we execute that, it's going to cycle through and print out 0 through 20. We're also going to have for loops inside of Scala, and here I'm going to show you a couple of them. If you want to cycle between 1 and 10, we're going to go I, put that little caret symbol there, and we'll go 1 to 10, and just to show you that we can do it without the brackets, we can go print line I, and you can see it printed that out perfectly fine. And of course all this code here is available in the link underneath the video. We could also go random letters like this, and I could throw all the different letters in the alphabet. And here we're going to use a different type of for loop that we're going to use until here. And this is very commonly used whenever we want to loop through strings or arrays. So we'll go 0 until, and we could say random letters, and if we want to get the total length for that, so it's going to cycle through there as long as the letters are available for us to print out. And then if we wanted to come in here and print out specific letters from this string, we just go random letters, and then inside of there, instead of our square brackets, we put those inside of parentheses. That's a common error, so I'm just pointing that out. And you can see there it went through all the different letters and printed those out on our screen. So that's how we'd use until. You can also use a for loop to iterate through a list. So let's go and create ourselves a list, and this is how easy it is to create a list. Just go list like that, and there we go, 1 through 5 for our list. And then we can just go for I, temporary holding cell for each item in our list, a list. And then of course we could go and print out those list items, and then a plus sign at the end to concatenate those together. And it tried to print out that list, but I messed that up. So let's go in there and do that. And again, put I inside of there. And now you can see it printed all the list items out. So there's a bunch of different ways we can use for loops. Another thing that's kind of neat is we can throw an if statement inside here. So let's say we wanted to cycle through a list and only store the even numbers. Well, we could go variable, and we'll say something like even list is equal to 4, and then inside of this we'll go I 1 to 20. So let's say we wanted to go through all the different list items from 1 to 20. We could then inside of this guy say if I and the modulus of 2. So anytime we would check for the modulus of 2, and it would be equal to 0, we know that we have an even number. And then down here, after we close off that curly brace, we go yield I, and the value of I after it cycles through this list is then going to be stored in the even list, like that. And then if we wanted to print out this new even list, of course, we could just go for I and even list and print line and I, and there you can see it printed out all those different list items. So that's just a different way to filter through a list, and there are many other different ways to use filters inside of Scala, and of course we'll take a look at those as well. We're also going to be able to assign or increment through multiple different variables with our for loops. So let's say we wanted to iterate through I, and that's going to go from 1 to 5 like this. Here we'll put a semicolon because we need that because we have more than one statement. Then we're also going to iterate through using the variable j between the numbers of 6 and 10. And basically what this loop is going to do right here is it's going to cycle through the first value in I, and then it's going to print out all the different values in j, and then increment I, and then proceed to work with j over and over again. Probably makes more sense if I just go in here and show you how it works. So I'll just go print line I, print the value of I there, and then we'll do exactly the same thing with j. Let's just change this to j, and there you can see exactly what it did. So when it printed out the value of I, which is the first increment, and then it printed out 6, 7, 8, and 9, and then it incremented the value of I, and then printed out 6, 7, 8, and 9, and so forth and so on. And whenever we take a look at multidimensional arrays later on, you're going to see how useful that can be. Another thing it's important to know is that there are no breaks or continues inside of Scala. However, you can kind of knock that off. And how we're going to do that is we're actually going to create a function here, and I'm going to call this print primes, and that's how we create functions. We type in def. Inside of this, I'm going to create our prime list, create a list like this, and then we can say something like 1, 2, 3, 5, 7, and 11. We could then cycle through all these different guys, by going prime list. And then if you wanted to implement something that would work like a break statement, we could say something like if I is equal to 11. In that situation, we want to jump out of this function altogether. So you can just type in return, and that's exactly what that's going to do. So that's a way you can implement break inside of Scala if you're really missing it. And then we could also basically knock off a continue statement by just throwing in an if statement here. So we can say something like, hey, 1 is not a prime. Well, we could say if I is not equal to 1, then we're going to print the value of I, otherwise we're going to end this and jump back to the beginning of this loop. And then you can see, if we get completely out of here, exactly how we would call for this function to execute. We just go print primes like that. That's how easy it is to execute a function. And you can see there, it printed out all the prime numbers. So that's not only how we define functions, but also how we cycle through lists, and also how we can implement break and continue even though they're not pre-built inside of Scala. So now let's go take a look at how we can handle input and output. So let's create a variable, and let's call this number guess, and just give it a value of 0. Here you're going to see a situation in which a do while is going to make a lot of sense, because we definitely want to loop through it at least once. And we're going to say print. If you don't put print line at the end there, it isn't going to issue a new line. We could say guess a number. If we want to get input from the console, we could just go number guess, and then we'll go read line. If we want to read in the data as if it's a string, which is probably a good idea. Then if we want to convert it into an integer, we would just go to int. And if you're wondering, you could also come in here and go read int, read double, read byte, read short, read long. Okay, so if you wanted to, or you were absolutely positive you're going to be reading in those different data types, you could do that. Otherwise, you could just always read in strings and then convert them to your chosen data type, which is what I normally do. And then at the end here, after we cycle through this at least one time, we can say while number guess is not equal to 15, we're going to continue asking them for numbers. Then of course after this, we could say print f. Another way of outputting to the screen, you could say you guessed the secret number. If we want to throw an integer inside of here, just put a % and a D, and you're going to need a new line there because printf doesn't allow you to get a new line any other way. And then we could put 15 right there. And this guy right here is going to juxtapose directly inside of there. And I'm going to show you more about printf and a whole bunch of other different things. And I got a little bit of an error here about deprecation. Let's go and fix that. So let's jump up here, and we're going to create an import. Let's import a couple libraries actually. If you want to import libraries, you just type in import, and I'm going to get scala.io.standard_in like this. And if I want to specifically just get two different functions here, I can go read line, which is what that little warning is complaining about. I could also do read int, do whatever. I had my math library. I showed you how to import that inside of the terminal. You do it pretty much the same way inside of the compiled version of Scala here. And then I'm also going to import a library for using array buffers, which we'll see later, and print writer and source, which is going to allow us to print to a file and then read from a file, which we're going to see here in a moment. And then we'll come in here and execute this, and now you can see we didn't get the deprecation warning, so that went away. And you see if we type in all these different numbers, it's going to continue asking us until we get the right number. So that's exactly how we would import data or get data from the console. And a couple different ways we can print that information out. Now let's go in here and cover a couple other different ways to output data. Let's create a couple different variables. There's my name, age, weight, and I'll show you how we can use some styling using print line. You could also come in here and type in S like that, and we'll be able to go hello followed with whatever the variable is that you'd like to print out there on the screen, and that's going to work well. We're also going to be able to go print line and put an F in front of it like that, and then you'll be able to say something like I am and a $, and you could put age. You could perform calculations directly inside of here if you'd like, and weigh, and I could go weight, and let's say that I only wanted my weight or my double here in this situation to only show 2 decimal places. That's exactly how you do that, and then you put an F at the end of it like that. And of course you're going to want to make sure you put an equal sign inside of there. And you can see here hello Derek prints out, and it also prints out I am 40 and weigh 175.5. So some other interesting ways which we can output information. And basically the styling characters you're going to use, like right here we have F with the doubles and all those other different things. You're going to use a $C for your characters, $D for any different integer types that you want to use, F of course for any floating point numbers, and then S for any strings. couple other things we can do here. We could go printf, which we're going to use a lot, and let's just talk about justification, how that's going to work for us. If we wanted to have this right justify, let's say with a total of 5 spaces like that, and I'll put another quote inside of here just so we can see that the justification's taken place. Could do it that way. We could also do left justification by putting a minus sign inside of there, and you can see how it's justified. See, it's right justified there with 5 spaces, left justified there with 5 spaces. Could also come in and do a couple other weird things, like let's say we wanted to do 0 fill. You could throw a 0 right there inside of there, and see, threw in those 4 zeros to fill up that space. You've seen this before, but let's say we wanted to come in and do 5 decimal places, and we could do something like 3.14, and then since this is a floating point number, throw an F inside of there, and you can see it went and threw in those decimal places. You could also do left justification using strings, so this isn't only tied to using numbers. Say 5 and then an S, and then we'll just throw something like high inside of here. See, high, and how that's justified. And of course you can right justify as well. And the other different, this guy right here is a new line. The other different special characters you're going to use a lot. B for backspace like that. There if you want to use a backslash, and then maybe A if you want to do an alert sound or something like that. But for the most part, you're not going to use any of the other special characters. And I'll get more into inputting and outputting data here in a minute, but let's jump over and take a look at strings. Okay, so we already created strings here in the past, so no use in going over that. Just throw them between double quotes, and there you go, you got a string. Now if you'd want to print out, let's say a specific index, like the 3rd index for your string, of course we would just come in here and go random sentence, is what I'm saying there, and throw in 3 inside of that, and you get A out of that, which is going to be this guy, because it starts at 0, 1, 2, 3. So that's the 3rd index inside of there. Starts at 0, of course. We'd also be able to come in here and get the string length, which is very useful if we're sorting through a string, by just going random sentence and then typing in length like that, and you can see it printed out 21. We'd also be able to come in here and concatenate strings, or combine strings if you want to use a less fancy term, and we can just go random sentence, concat like that, and explode or something like that, random, and there you can see it combined those for us. We're also going to be able to come in here and compare strings, say something like our strings equal, and then we can just go I saw a dragon, and then go equals, and then go random sentence, and we execute that, and you can see that comes back as false. And of course this should be our strings equal. There we go. But either way, we could also go through our string here and find a match. So let's say we wanted to find where dragon shows up inside of the string. We could say dragon starts at index, and of course we could go and put this down at the bottom here, keep this a little bit neater, and then to find it we'll go random sentence index of, and then we'll put inside of here the string that we're looking for inside of that string, and you can see that it pops back. The index starts at 8. And another thing that's useful is we can take our string here and convert it to an array. So we can go val random sentence array is equal to random sentence, and then just go to array like that. And then of course after we do that we could cycle through it. We could cycle through the string. I already showed you how to cycle through strings before. Random sentence, and we'll get more into arrays here in a second, and print line V, and you can see it printed out all that along with all the different spaces on separate lines. And that's most of what we're going to talk about strings here. Get more into them a little bit later. Now let's take a look at functions. Now your basic function is going to start off with def like that, and then whatever your function name is, then you're going to have your parameters, and they're going to have a colon followed by whatever that parameter's data type is. And that's going to continue as long as you have more and more parameters. This is then going to be followed by another colon and the return type. And then there's different ways of using equals to and curly brackets, which I'm going to show you here through examples. Then you're going to have function body, and then you're going to have your value, whatever you want to return. And you can either use return or not use return, as you're going to see here in a couple of these different examples. So let's create a whole bunch of functions. Let's create one called getSum, and it's going to have a parameter called number1, and we're going to have this be an integer, define it as an integer. If you wanted to come in here and give it a default value, you of course could give it a default value. We could then go number2, also an int, has a default value of 1, and the return type for this function is going to be integer. And then we could say equal to and a curly bracket, and then we could either put return inside of here or not. So in this situation I'm going to put return inside of here, and I'm going to add those two guys up right like that. Now we're going to be able to come in here and say print line, say something like 5 plus 4 is equal to, and then call our function by going get sum 5 plus 4 or 5 and 4, and you can see that printed that out on the screen. We're also going to be able to come in here and get rid of this return altogether and get exactly the same results. So sometimes you use return, mainly you use it just if you're used to other languages that use return, but other than that, Scala doesn't require it because it automatically outputs the value based off of the last line of code inside of your functions. Another thing we're going to be able to do is we could call this function, but let's say we wanted this, in this situation it's not going to matter, but let's say that we wanted to use named arguments inside of here so that num2 gets 5 and then num1 is going to get 4. We can do it that way, and of course you're going to get exactly the same results. And then we have functions that do not return values, and these are referred to as procedures inside of Scala, and they're defined in the same exact way. We could say hi. See, there's no parameters inside of there. In a situation in which you're not returning anything, you're going to put unit inside of there, and then we can just throw a simple print line inside of there. And then this function, of course, can be called just by going say hi. Don't need to do anything else. And you're going to see how the prints out there on the screen as well. Could also come in here and receive a variable number of arguments. So we could do something like another version of get sum. Here we'll go args, and this is going to receive a bunch of integers, so we're going to put a star there at the end of there. It's then going to return an integer after it performs its calculations. Inside of here we could create something called sum integer, give it an initial value of 0, and then create a for loop num, and then we could refer to or cycle through all the different arguments that were passed in. Sum plus equal to whatever the number is currently inside of there, and then we can put sum right there with no return value, and it's going to automatically send that back to us, whatever the value of sum is. And if we wanted to print out these value, we could come in here and go get sum like that. Get rid of this extra one, and you can see if we execute that, that's going to print out 21. Just make sure you don't have, I had a little extra comma there, I got rid of that. So that's how you can receive a variable number of arguments and perform those or work with those by cycling through them with a for loop. Let's take a look at recursion, which is something that confuses some people. Here we're going to do the normal example that's used with factorials to explain how recursion works. This is going to receive a number, and let's make it a big int because these guys can get big, just to show you exactly how we would receive and then return a big integer in a function. And we'll go if num is less than or equal to 1, we're going to return 1 from that. Else num times, and then factorial, this is the recursion part where it's calling, a function is calling itself, and I'll give you an example of exactly how this is going to work when we go in here and actually run it first. Call the factorial, pass in a 4 inside of it, execute it, and then we'll go through exactly how it works. So you can see right there, it comes back with a final value of 24. Well, how exactly does that work? Well, let's walk you by step. What it's going to do in its first pass through this is num, of course, is going to have a value of 4. That's going to be multiplied times factorial of 3, whatever the value of that is. Second time through, num is going to have a value of 3. Why? Because, see, we're calling factorial again. So we get to this point, and then we're going to be multiplying that times whatever the factorial of 3 minus 1 is, which is going to be equal to 2. And then the third time through, factorial now is going to be 2, which comes from right there, goes right there, and then we're going to call factorial of 1. What do we say here? If num is ever less than or equal to 1, we're going to give it a value of 1. So factorial of 1, what we have right here, is also equal to 2 times 1. So what's the value of that? Well, that's going to be equal to 2. So that's going to come up here and replace this. So what does that give you? That gives you 3 times 2, which is going to be equal to 6. This, of course, is equal to 2. So where does this 6 go? Well, it goes right here. And that gives you the final calculation. That gives you your final factorial, which is 4 times 6, which is equal to 24. So that's exactly how we would work with recursion inside of Scala, and exactly how it works in regards to calculating factorials. Now let's jump over and take a look at arrays. Now when it comes to should I use an array or an array buffer, it's basically going to come down to one thing. You're going to use arrays whenever the size of the array or the number of pieces of data are going to be fixed, you're going to use an array buffer whenever you're going to have a variable number of data stored inside of an array type structure. Now if you want to create, I'm going to cover both array buffers and arrays, of course. So let's go and let's just create an array called favorite numbers. We're just going to go new array like that. We have to define exactly what the data type for our array is going to be, and then we have to define this size for an array. You could also come in and define an array and also initialize it all in one line. So Bob and Tom are my friends in my friend array. You're going to also be able to come in and change the value in an array just by pointing at index 0, which is going to be Bob in this situation. Change that to Sue, and we could come in here and print this, of course, by going best friend and then friends, and let's just go 0 inside of there for the first index. You can see best friend Sue pops back, and this is versus working with an array buffer. Array buffer, let's just go and create an let's call this friends 2. Array buffer is also going to require us to come in and define what type of data type we want inside of it, which is going to be a string, and there we go. But you can see I left the length part out because that's not going to matter with an array buffer, because an array buffer size can change. See, we could also come in here and go friends then and insert into the 0 index. I could throw fill. I can also come in and add an item to the next available slot just by going friends 2 plus equal to. And let's say we want to throw mark inside of there. That's going to work for us. We could also come in and add multiple different values just by going plus plus equal to, and we could just structure this like an array, and it's automatically going to fit right into our array buffer. So let's say we got Susie and Paul. We could also add items starting at the second slot, so we can go friends 2 dot insert, and second slot in this situation is going to be 1, and we can go Mike, Mary, and Sue. You can see we can add a whole bunch of values all at one time. We could also come in and remove an item. So we could say remove 2 elements starting at the second index. Well, the second index is going to be 1. And there's the 2 items we want to remove. And then we could come in here and cycle through these guys. So let's just say friend. Let's create a string equal to, give it an initial value of nothing. And then if we want to cycle through them, of course, temporarily store them in the friend variable. Friends 2 is what we're going to be cycling through. And then go print line friend. And you can say it went and printed out Phil, Sam, Mary, Sue, Mark, Susie, and Paul. So that's how we can insert, remove, and do all kinds of other different things with array buffers. Let's go and use the favorite numbers array up here just to show you how we can fill an array in other different ways. Let's try using a loop here because that's kind of easy. Let's go J, and then we'll go 0, 2, and then if we want to get the length of our array, like that, -1, that's going to give us all the different values inside of our array that we're going to be cycling through. We could then go favorite numbers, and the J index is equal to the value of J, which we're going to be storing inside of that array. And then we could just print this out on a screen just to show you what that looks like. Favorite nums, and then throw J inside of there. And there you can see it printed out 0 through 20, or through 0 through 19 in that situation, out on the screen. Another thing that's kind of cool is now that we created this favorite numbers, or we stored data inside of here, we'd actually be able to cycle through these and perform multiple different calculations on them using yield, like we used yield before as a way to format data. So you could say favorite numbers times 2 is equal to, and we could do this all in one line. We could get for num holding cell for favorite numbers array, which is what we're going to be cycling through, and then we could say yield and 2 times num, which is the value there. Don't need to do anything else with that, and that's all going to create another array for us in which all those different values are going to be multiplied times 2. Another thing that's cool is we can now take this guy, favorite numbers times 2, and another way that we could print out those is just by going ForEach and then throw print line inside of there, and it's going to multiply all those different values times 2. As you can see, it did right there on the screen. Another thing you could do, which is neat, is we'd also be able to store values that match conditions. So we'll say favorite nums divided by 4 equal to, say 4. This is more of the functional part of Scala, what you're seeing here. So we can say favorite numbers and then throw a condition inside of here, if number modulus 4, so this is going to tell us if this is a multiple of 4 or not, is equal to 0. And here we can use yield again. There's yield. Here we're not going to perform any calculations on it. We'll just have that be number just like that. And then let's use our favorite numbers divisible by 4. and we'll use our little ForEach trick here like we used before. And you can see right there it's only printing out all those values that are evenly divisible by 4. So that's pretty cool. We could also come in, of course, and create multi-dimensional arrays. And we'll be able to just go let's create a multiplication table here. And with multi-dimensional array, you need to go array.of_dim, and then you're going to define the data type that's stored inside of it. Then you need to decide or define the size of the multi-dimensional array. Let's just make this 10 by 10. We can then go for cycle through 0 through 9 for this guy. Use curly brackets in this situation because I feel that it makes it look a little bit better, make a little bit more sense. And let's cycle through 0 to 9 again for the second part of this guy. And then inside of here we can go multi-table, value for I, value for j, and then let's make those equal to I times j. And then to print them out, you're basically going to do exactly the same thing. So let's just copy this for loop, except in this situation we're going to print those values out. So let's use printf in this situation just to demonstrate using printf. So we can say the first integer and the second one is equal to, or the indexes, whatever you want to think of them as. And we'll throw in a new line, and we'll throw I and j, and then if you want to get the value from the multi-dimensional array, just throw the I part in there and the j part in there as well. And there you can see it printed all those different multiplication tables out there on our screen. That's how we can use multi-dimensional arrays. Another thing that's kind of neat is we could also come in here. There's a whole bunch of different functions that are available to us. So let's say we wanted to sum all the values in an array for us. We can do that with sum, which you're going to say favorite numbers, and you can play around with this in a terminal and just type in that value followed by dot, and it's going to show you all the different functions that are available to you. And you're going to be able to do, there's a whole bunch of functions. I'll just cover a couple of them here. We'd also be able to come in and get the minimum value inside of that array with min. We'd also be able to get the maximum value inside of there with max. And there you can see the sum of all those values, the minimum and the maximum. Do some other cool things here with arrays. We could also sort them. So we could say sorted nums is equal to favorite nums, and we could sort them ascending or descending. So we can say sort with, and you'd put an underscore there, greater than sign, and another underscore there. And this is going to give us a sorting of descending. If you wanted ascending, you'd put it this way, descending this way. And then another little trick is we can return an index sequence and convert it into a string with commas. So let's show you how that works. Let's just use print line here, and we could go sorted numbers, deep, make string, like that. And then if we want to separate it with commas, we just put it in there like that. And if we execute it, you can see it did. Say it automatically because of this guy right here. Put it in descending order, and then with this guy right here, convert it into a string we could print out, and also through commas inside of there. So there's a whole bunch of really cool things we can do with arrays and array buffers and all the other different things we covered here. Now let's take a look at maps. Now a map is a collection type, just like arrays and array buffers, except they're going to store what are called key-valued pairs. And to create a map, let's go and create one for employees. Spell employees right. There we go. And to create a map, we just go map, and then this is going to be the key. So this is manager, followed by a dash, like a little arrow. And we could say Bob Smith is the manager. And we can put as many of these in here as we would like. This map in this situation is going to be immutable, which just means the values can't be changed after they're created. I'll show you how to create mutable ones as well. And secretary, and then let's have Sue Brown be the secretary. We could then get the value from this employees map, and we can say contains. We can check to make sure that employees, boy, I keep spelling employees wrong. There we go. Don't really like being an employee, can't spell it right. Alright, so let's check that the map actually contains a manager key first before we ask for it, and that's how we would do that. And then in the situation which we find that, let's use printf this time. We could say manager, there we go. And then if we want to get manager, or the value for the key manager inside of our map, we just go like this, and you can see Bob Smith pops right back there. Like I said, we can also create mutable or changeable maps. So let's create another one called customers. How we would do that is we would go collection dot mutable and then map. and then we come in and let's just say the key in this situation is going to be 100 and have that be Paul Smith. And then the next one, let's have that be 101. These all have to be different. They're keys. That's important. And Sally Smith. And there we go. We just created a customer map that's mutable, changeable, whatever. We could then go printf, and we could say we want customer 1, and to get it, of course, we're just going to throw in the first key inside of there, and you can see Paul Smith pops back as the first customer in our list. We could also change the value using our keys. So let's say we just reference customers, which is the map, 100, and let's say we want this to be Tom Marks instead. Now it's Tom Marks. You could also add an item because this is a mutable map. So customers, can't do this if it's immutable. And we could have this be Megan Swift. And then if we wanted to output both the keys as well as the values, we could use a for loop for that. See, I told you I was going to cover a lot more with for loops like this. And the map we want to work with, which is customers. And then we could say printf, and we could get the key. So we're going to use D there, of course, because it's an integer. And then that's a string right there. Throw in a new line, and now we can just get the key, throw it where it needs to go, and the value, and throw it where it needs to go. And if we do that, you can see it prints out the keys and the values for everything in the map. And that's the vast majority of what we need to know about maps. So now let's go and take a look at tuples. Now tuples are going to hold values of numerous different types, but they're normally immutable. So let's go and create a tuple. So we'll just call this tuple Marge is equal to, and let's have this be, let's say it's an ID of 103, Marge Simpson, and let's say that she owes us a balance of $10.25. We would then be able to come in here and print information out here. So it's a string, owes us, and we could say how much it owes us. Let's say we only want, well, let's throw a $sign inside of there first. We only want 2 decimal places. And there we are. And now if we wanted to get the values inside of there, we would go tuple Marge, and this is a little bit weird, _2. So we want Marge Simpson, so this guy right here. The second, this would be the first, this will be the second, this will be the balance. And then we would also go tuple Marge like that to get the actual balance that's owed. And you can see Marge Simpson owes us $10.25 pops back. If we wanted to iterate through a tuple, we could use a product iterator. So let's go tuple Marge product iterator, and then call ForEach, and then go and get all those different values and print them out on the screen. And there you can see, printed all those out on the screen, all on separate lines. And if you'd want to convert a tuple to a string, all you would do, let's just go into it inside of a print line. We could say tuple Marge and call toString on it. ToString's available for a lot of different things inside of Scala. And you can see it printed out all that information for that tuple. So that's a rough overview of how we're going to use tuples. Now let's take a look at classes. Okay, like any other object-oriented programming language, classes are going to be used as blueprints to create real-world objects. And those objects are going to define attributes, which are called fields in an object-oriented world, and capabilities of those objects, which are called methods. And we're going to define them outside of main. I often like to figure out or print out little comments here or exactly where the different parts of my language or my program begins and ends. Just helps me guide my way through here. And how we're going to create a class, let's create a class called animal. And you're actually here going to define the default constructor and the different fields you're going to use right here, right after we define class and whatever the class name is. So this class is going to have a string. It's also going to have a sound. You can see I'm using var here because I plan on these changing, or basically I'm deciding that they may change. And there we go. So first thing I want to do here is also, before anything else happens, this is also part of the default constructor, which is going to be the function in the code that's going to execute first whenever a new object of type animal is going to be created. This is a little bit weird. So what I want to do here is I want to call this animal, and I'm going to call a function I'm going to create here in a second called setName, because I'm going to have some of this data be protected so that we will be able to verify or only allow certain names to be assigned to certain animals. So this in essence right here is a constructor where we are going to be accepting a name, we're going to be accepting a sound, and we're specifically going to allow them to set the name how we define them to allow it to occur. Another thing that's a little bit odd with Scala is that there are not static variables and static methods like in Java, for example. And we're actually going to create one of those here in a second. And how I'm going to do that is I'm going to give every animal an ID, and it is going to call a type of static function that I'm going to call new ID number, which we'll create that in a second. Just give me a moment to structure everything out here. I could, however, if I didn't define the name and sound and things like that up here, I could come in and do something like protected variable name is equal to no name, but I'm not doing that in this situation. I'm going to have everything done up here in the primary constructor area. And there's also protected and private and public inside of Scala, just like there is inside of Java. Protected just means that the field can only be accessed directly by methods defined inside of the class or by subclasses. Classes that are going to inherit from this animal class right here. We'll see inheritance here in a second as well. If this is marked private, fields can't be accessed by subclasses or classes that inherit from animals. And if it's public, it's basically going to be data that can be accessed from anything. But like I said, I'm not going to use that here because I'm defining all those different types up here inside of my primary constructor, which is what Scala calls it. I'm now going to come in here and define getters and setters that are going to be used to protect our data. Now the get name part isn't really going to protect anything, it's just going to return values. And you can see that it's going to work just like any other function that we've come across here so far. It's just going to go and get the name that's stored inside of here and output it. You can also see we're going to do exactly the same thing for get sound, except in this situation, of course, it's going to return whatever the value for sound is. Now let's come in here and create the set name part for us so that we'll be able to see exactly what's going on there with that guy. So set name, whenever it's called, is going to receive a name, which is going to be a string data type. And let's say that I do not want them to be able to have numbers inside of the name that they pass for the animal. Okay, I'm just throwing this out here just as an example of how we would like to protect our data. And we could say if not, and then we could say name, and this is where we have regular expressions right here. I'm not going to get too much into regular expressions. I have other tutorials on regular expressions. But basically what I'm saying here is I'm looking for a match in which I have any decimals, any numbers inside of this string. And I'm saying if the name that they passed in here does not contain any decimals, any numbers, well then I want to work with it. And under that situation, if I want to refer to this animal object's specific name and assign a value to it, I'm going to type in this dot name is equal to name. However, in situations in which they did pass in a name that contained numbers, in that situation, I'm going to say this dot name, and I'm going to protect that data. That's why I'm using getters and setters, and I'm going to give it a default name of no name to show that it was not set. We can also come in here and do the same thing with set sound, except in this situation I'm just going to let this be perfectly fine, allowing them to directly go in there and change the sound for my animal. And once again, if I want to change the specific sound, I just do this sound and pass in sound. So you may say to yourself, well, what happens if they try to create an animal object but you do not have a name or a string or whatever? Remember, this is the default constructor that's going to be called to create new animal objects. Well, we can also have a whole bunch of other constructors. So let's create one. How you create other constructors is you define this. This is a constructor inside of Scala, and in situations in which they only pass in a name, in that situation, I'm going to call the primary constructor, and I'm going to say no name is going to be the name I assign for my name, and no sound is going to be assigned for the sound. See, they didn't pass in a sound, so I am not going to have one to pass up here to this guy to assign. So I'm just going to let it be the default right there. However, they did pass a name, so I'm going to go this set name like that, and then call this guy up here to verify if it's a valid set name or a valid name, and if it isn't, give it the value of no name. So that's how we would handle if they passed in a name. Let's also cover if they do not pass in a name or a sound. Well, we're going to go define this once again. I'm not going to put any parameters inside of there because we don't have any. And in this situation, we'll just go this, and then we'll go no name, and we'll set those values for us. No sound. Okay, so those are the constructors, and they work very much like they work in other object-oriented languages. You can also override methods. So one method that is available in Scala with every object you create is called toString. If I want to override any method, whether it's pre-built in or I want to override a method whenever I inherit from it, I just type in override toString, and then I can define exactly what I want it to do. This one's going to return a string. And then if I want to format a string, I could do something like return and throw in a string there with the ID. I'm going to show you here in a moment how to get that ID part there. D says S like that, and then I could call dot format like this, and then go this name like that, this dot ID, and this dot sound, and that is how we can format a string that we're going to be returning from a function or method as well. So that's how to override, and that's how to format a string, and that's how to do a whole bunch of different things. I'm going to run this in a second so you can see everything and exactly how it works. First thing I wanted to do, however, was to get back to this ID part. Remember up here I said I called a function, and we're going to have to do new different ways of creating static methods or static functions inside of Scala versus what we would have inside of other languages like Java. Now what I'm going to do, I'm going to make sure I'm outside of this class area, and I'm going to come down here right afterwards, and I'm going to create a companion object for my class, which is where we would be able to find static class variables and functions. And how it's created is you go object and give it exactly the same name as your class, so it's going to be animal in this situation. And you want to create a static, that's what it's called in Java, field. You would go ID number is equal to 0 like this, and private, and we could create a static function, new ID number is equal to, and then inside of here we can perform some operation, like we can take this number and just increment it so that we will know that each animal object is going to have a unique ID, and then after it does that calculation it's going to return the ID number. So that's how we would create static fields and static functions inside of Scala as well, and that of course is what this is referring to. See, new ID number, and if we come down here, a new ID number, this is a function. So now let's go and create some objects using this class. Come back up inside of main. I'm going to create one. I'm going to call it rover, and I could just go new animal like that. I could then come in and go rover dot set name and pass in rover like that. Just make sure I don't put a number inside of there, otherwise it's not going to like it. Set sound, and I could just say wolf like this, and then I could print out some information on the screen. And how I'm going to be able to get this data is just by calling rover get name, rover get sound. Come down inside of here, see, get name, get sound, those functions right there are exactly what I'm calling, and you can see right there rover says wolf. So pretty simple. And you can also see that this is going to work whether I pass in a name and sound or I do not, because I set up all those different constructors we had there. Likewise, I could also come in and create a cat type of item here, new animal, and in this situation I am going to pass in the name and so forth whenever I first create it, and meow. And why don't I show you another different way that we can work with objects using print line. So we could go like this. I could also come in, if I put that little S inside of there, put $sign like that. Let's close that off so it stops flipping out, and I would then go whiskers like this, get name, and that's going to work with ID, and I could go and get my ID that was assigned to whiskers. ID says, and then I could also put another $sign inside of there and go whiskers sound like that, and then of course close that off with the curly braces. And why don't I also come in at the same time and go whiskers, and let's also call that toString function. Well, let's also throw this inside of a print line, because toString returns a string, doesn't print a string. And you could say whiskers with ID 2 says meow, whiskers with the ID 2 says meow. They both do exactly the same thing. Just wanted to show you a different way of outputting that information inside of printline. Now let's talk about inheritance and how that's going to work. So I'm going to scroll down here past my animal class and this animal object we have right here. And basically a class that inherits from another is going to of course gain all of the class that it's inheriting from, all of the fields and methods defined in animal in this situation. And the only way that can't happen is if this guy up here is declared with final. So if you do not want a class to be inherited from, declare it as final, and you won't be able to do that. But let's come in here and let's create a new class called dog. It's also going to receive a string a sound. However, because it is a dog, it's also going to have a growl. Now, if you want to inherit from the animal class, we're just going to go extends, and then you're going to define name and sound, which is going to be passed over to that class. And then put curly brackets, because remember, animal receives a name and a sound whenever all the animal objects are created. We can stretch this out here so you can see all that on the screen at one time. Then inside of this guy, we're going to create all the constructors we're going to need. So the default constructor here is going to be this. Going to receive name. It's also going to receive, remember, this is the default constructor up here. It's expecting a name, a sound, and a growl. If it doesn't get a growl in this situation, we need to handle that. So in those situations, we're going to say this and go no, name. We can pass in sound because we got that. And we're going to pass in no growl because we didn't receive a growl. And then just like before, we're going to do some checking on the name to make sure the name is a valid name by calling set name on that. And this is going to be able to call the set name, whoops, make sure it's the same, set name there, set name here, uppercase. Make sure those are exactly the same, otherwise this will not work. So that's a constructor we'll use if we only get 2 of the values passed over. And then we'll go and define what's going to happen if only a name is passed over. And here we'll go this, and we'll say no name, no sound, and no growl. Because in this situation we only received a name, and then we're going to verify again that the name is okay by passing name inside of there. And then the final situation, constructor-wise, is we'll go define this, and we'll have to handle if they don't pass anything inside of it. And under that situation, we'll just go no name, no sound, no growl. We can also, of course, override any methods that are defined in our superclass in exactly the same way. Override, define, toString. It's going to return a string just like the last guy did. And let's just copy this because it's very similar. Paste that in there. And then we'll just say says S, or throw in our growl right there. And then at the very end of this, just change this to growl like that. And now that we have that saved, we can jump back up inside of main once again, and we'll work with our dogs that we created. So let's create a dog called Spike is equal to new dog. And then we'll just go and define everything inside of here just to keep this simple. So his name is Spike. He says wolf, and he says grr. There's that new object. We could come in and go spike.setName, call that directly right afterwards. Make sure that's uppercase, and we'll just leave his name Spike as well. You could throw in Spike1 just to see what happens on your end. Print line, and then go Spike toString, and there you can see it says Spike with the ID 3. As you can see, it automatically kept this object here and automatically kept generating ID numbers. It says wolf or grr. So that's how we can work with inherited values. Now let's take a look at abstract classes. Now an abstract class can't be instantiated, and it's made up, instantiated means create an object from it, okay? And it's going to be made up of both abstract as well as non-abstract methods. And how you create one, now I'm going to show you what those look like. Abstract class, that's how you do it. And let's stick kind of with what we did before. Let's say mammal, and let's say it's going to get a name string just like before. And this is what we call an abstract field, move speed. It's just going to be a field that does not have a value assigned to it. So move speed. And an abstract method, likewise, is only going to define the parameters it gets, which this doesn't get any, and it's going to have return type. So there's no method body to it. What you can do, however, with this is create another class, and let's call this wolf. And it is going to have a name and a string. And then we can say extends mammal, which gets a name. And then inside of this, we can define our move speed. So move speed default's going to be 35.0. And then we could do something like define a function called move. And it's just going to print out the name of the animal as well as the move speed for that animal. And you can see exactly how that's all structured. Now what we're going to be able to do is go back up inside of main. We can get rid of all this stuff. And let's create a wolf type that is called fang. And go new wolf. And we'll pass in the name. Then we can say call the move speed for us and set that to 36.0. And then if we want to print out the move information on fang, we can do that very easily. And you can see the wolf fang runs 36 miles per hour. And that's basically all you got with the abstract classes. Now let's take a look at traits. Now a trait is more like a Java interface in that a class can extend more than one. Then, for example, we couldn't extend multiple classes and we couldn't extend multiple abstract classes. However, we are going to be able to extend multiple traits. The only difference is unlike Java interfaces, traits can provide concrete methods and fields. And how we're going to create one is we'll say something like trait flyable, and we can define fly. This is a method. We could then come in and also create another trait. Let's say we're going to do something with superheroes. So let's say that our superheroes can fly and maybe they're bulletproof. We'll define hit by bullet. What's going to happen if our superhero gets hit by a bullet. And then, like I said, we're also going to be able to define concrete classes, which is different than we can do with Java. So we could do something like calculate the speed of a bullet after it hits our hero. And it's going to receive a double and return a string. So how is the bullet going to ricochet, or what's going to happen when the bullet ricochets? And here we'll basically just say that the bullet is going to ricochet off of the character, and we're going to decrease the speed of the bullet by 75%, just to keep it nice and simple. Now we're going to be able to use these traits to create another class. Let's call this superhero, and it's going to have a name, which is a string. Let's just have it be that. And let's have it extend multiple traits. So it's going to have flyable. And if you want to have any further after that, you have to put width down. And then you would follow this up with all of the other possible traits that you'd like it to have. We'd then be able to come in and define what happens, or define the fly method. So you could say flies through the air, and then format, and then this name. And then we could also define the hit by bullet function, and we could just say the bullet bounces off of, and then put our character's name there, format this name. And then up inside of main again, we can create a superhero. So we'll go val, and we'll just create Superman in this situation, new superhero, and we'll pass in Superman because that's his name. And then we could do some print lines, Superman fly, what's going to happen in that situation, and we'll do all these other ones too. And we'll say hit by bullet, Superman hit by bullet, and then we can also call the other function which is going to handle ricochets, and we can pass in 2500 as the speed of the bullet. And whenever we execute that, you can see Superman flies through the air, the bullet bounces off of Superman, and the bullet ricochets at a speed of 1875 feet per second. So there's an example of traits and how they can be used. Now let's take a look at higher order functions. Now functions can be passed just like any other variable, and let's just give you an example. So let's say I want to do the log10 function is equal to, well, if I want to copy this function and what it does, I just put log10, that's the function I want to copy and store in log10 function. However, you're going to need to put this underscore here after the function to state that you meant the function and not another variable or whatever, which would cause an error. And then we can just come in here and go print line, log10 function, like this, and then throw 1000 in there. And you're going to see that whenever we execute that, that is going to print out our answer there. So nice to know that we can store those functions. Now let's do something a little bit more interesting. You're also going to be able to apply a function to all items of a list, for example. So let's say you have 1000, just to keep this simple, 10,000 maybe. And how you're going to be able to do that is with a nifty function called map. So we can go log10 function like this, and then call ForEach, which is going to print everything out on the screen for us. And you can see that's exactly what it does. Prints out the 3 and the 4, which is the log of those functions. So that's something interesting we can do with map. Another interesting function is, well, let's show you another example of map because I haven't done much with it. Say we want to go 2, 3, 4, and 5. We could also go map, and we can accept a value of x, which is going to be an integer, and then have it perform certain calculations on everything in that list by just going x times, let's say we want to multiply everything times 50, for example. We could then go for each and print line, and you can see it went and performed those calculations on each of the list items we have there. Let's take a look at filter. Filter is going to allow us to pass only values that meet a certain condition. So we'll just create that guy, and we'll go filter, and let's say that we want to only get even numbers. So we can just put an underscore there for every item in that list and divisible by 2 and see if that equals 0, and then for each again and print line, and you're going to see that it only prints out the even numbers from those lists. So that's some cool stuff we can do with maps as well as filter. And now let's cover how we can pass different functions to different functions, or different functions into a function. So let's go times 3, and what this guy is going to do is it's going to receive an integer named num, and it's going to return whatever that is times 3. And then let's get another one, and let's have this one just be times 4 instead, and it's going to return 4 times whatever. Okay, so we just defined 2 functions we're going to pass into a function. Now we can define another function, and its point is that it's going to receive a function, and how we define that we're going to be receiving a function. And you don't have to type in func, that's just the name I'm giving to the function passed in. Well, make sure you put parentheses around this, and then you would put integer. It's going to receive an integer, and it's going to return a double. That's what that function is going to do. And this function, being mult it or multiply it, is also going to receive a number. So it's going to receive a function right here that's going to receive an integer and return a double, and it's also going to receive another integer. Well, now what we can do is take any function that's passed inside of it and perform different calculations based off of whatever was passed into it. And then on top of that, we could come in, let's say we want to 3 times 100 is equal to, and let's have this be 1 decimal place, and throw a new line inside of there. Now outside of this, we could go mult it, and then we can pass in the times 3 function that we want to perform for us. And you can see if we execute this, we're going to get 3 times that, and if we change this to 4, you're going to see that just that easily we're going to be able to just pass in any function we want and perform different calculations in that situation. A closure is going to be a function that depends on a variable declared outside of that function, and it's very simple. Let's just go val, and divisor value is equal to 5, and then we could go val divisor 5 is equal to, and here we'll go num, so it's going to be receiving a double, and then it's going to take num and divide it by the divisor value that was created outside of it, all on one line. Pretty useful. And we can say print line and then do 5 divided by 5. I don't know, not terribly interesting there, but whatever. And then we could say divisor value and pass in 5.0. Whoops, got a little bit of an error there. This needs to be changed to divisor 5, of course. Typed in divisor value, and there you can see how that works out. Okay, so there's an example of a closure. Pretty simple, just basically this is going to depend on a value that is stored outside of it. And there's an example of how we can use that. Why don't we also talk about file I/O? Now if we want to write to a file, first off we're going to need to get this guy right here and this guy right here if we want to be able to read and write from files. And to write to a file, let's just create writer is equal to print writer, and then you're going to provide whatever you want the name of the file to be. I'm just going to call this test text, and then I can call writer and write, and it'll write out whatever I want it to write to it. So I could say something like just some random text and throw in a new line inside of there, and then say some more random text, just anything. Close that off. And then after we write to it, we of course, when we're done with it, we want to say close, and that'll close that connection with our file. And if we want to read from it, we say val and text from file is equal to, and this is where we use source and specifically from file, and you're going to pass inside here file you want to read from, and then you're going to pass in UTF-8. And then you're going to go in and iterate over all the different lines of text that are inside of that file. So file, and then we can say line iterator is equal to text from file, that guy right there. Get lines is going to get me all those lines I want to iterate through. And then I can say for line like this, line iterator, and then quite simply just say print line, line like that. And then after we get all that done, we want to text from file like this, and then close that connection to that file. And if we do that, you can see that if we execute, oops, little bug slipped in there. Have to make sure we put new inside of there, execute, and there you can see it printed out all that. So that's how we write as well as read from files. Now let's take a look at exception handling. Alright, so let's just keep this really simple. let's say we wanted to handle a division by 0 error. How exactly would we do that? So we'll say divide nums, and this is going to receive a number, which is going to be an integer, and num2, which is also going to be an integer. Well, if we wanted to potentially catch an error, we're going to say try, and then inside of it, we could say num1 divided by num2. We know that potentially num2 could be a 0, and that could cause all kinds of problems. So we're going to say catch, and then inside of it, we can say case ex, and we're going to say java.language.arithmetic, and you can look up all these different exceptions that are available to you. Exception, and then we need to define what we want to print out. We can say something like can't divide by 0. And then after we have all of that done, we could do a finally block, and inside of here we could do some cleanup after exception, whatever you wanted to do inside of there. And this is going to protect us if we would come in here and say print line. An exception is just going to keep our whole entire program from completely collapsing if an error should occur. And in this situation, we'll just go divide nums, and then we'll pass in 3 and 0. And if we execute it, you're going to see there is our error message we printed out. So there you go, guys. There is a heck of a lot of information about Scala. Hopefully I answered a lot of your questions, and this will move you very quickly onwards to learning the rest of the language. And as always, please leave your questions and comments below. Otherwise, till next time.